Okay, this is Jasmine Schroeder, TeachIt video number 4, problem 4-1C, problem number 1. The question reads, prove the following, assuming n is a natural number. If n squared is odd, then n is odd. And then second part of the question is, if n squared is even, then n is even. So the way that we are going to prove this is by using the division algorithm, which says if a number is odd, n equals 2, and we're going to use q as our variable, and q is any whole number plus 1 is what the division algorithm says. So with that, then we can plug in whole numbers in for q and see that they're squared. So let's say we plugged in 1. We'll say q equals 1, then n equals 3. Let's say if we plug in 2, then n equals 5. We can plug in 3, which then n will equal 7. So you can see here that no matter what number we plug in, whether it's odd or even, with this equation here, the number does come out to be odd. So what we're going to do then, as this is representing just one part of the n squared, you can see it's just n, not n squared, we're going to go ahead and square this portion of the problem. So we're going to go q plus 1 and 2q plus 1. That way we're getting it squared or times each other. So first we're going to do these ones here to get 4q squared. Next I'm going to do these here, which would be 2q, and then these here, which would be 2q, and then the last, which would then be 1. So now I have this portion of the problem. What I can do from there, these would then be combined to be 4q. But what I would do from there is then simplify the problem. So we can take a 2 back out, like so. And this is n squared equals this. So then we would be left with 2q squared if we're taking a 2 out of here. Then with the 4q, we'll do plus a 2q, and then plus 1, as 2 cannot be taken out of the 1. This part here represents our any number q, which then ends up being any number q plus 1, which we know to be odd. So we can plug in numbers for this as well. We go 3 squared equals 9, 5 squared equals 25, 7 squared equals 49, 9 squared equals 81. So we have the equation n plugging in to the problem to prove that if n squared is odd, then n is odd as well. We're going to do the same type of thing using the division algorithm, for part B. With that one, though, instead of having the n equals 2q plus 1, it would just be n equals 2q. And then we would square this part of it here. So we would have n squared equals 2q and 2q, with q representing any whole number. And then we would be left with n squared equals 4q squared. If we take a 2 out of there, we're left with 2q squared. We can plug in more numbers for that. So if we want to go 2 squared equals 4, 4 squared equals 16, 6 squared equals 36, 8 squared equals 64, and so on. We can again prove that if n squared is even, then n is even.